How does structural plasticity change your brain's wiring? Have you ever wondered how your brain adapts and changes over time? The answer lies in a fascinating process called structural plasticity. This is how your brain physically alters its structure by forming, removing, or reorganizing connections between neurons. This happens in response to learning, experiences, or even the environment around you. When we talk about structural plasticity, we are referring to how the brain rewires itself. It creates new synapses, which are the contact points between neurons. It can also remodel dendritic spines, which are tiny protrusions on neurons that receive signals. In some cases, especially during early development, the brain can even generate new neurons. Neurons communicate through electrochemical signals that travel across synapses. Structural plasticity modifies the number and arrangement of these synapses, effectively changing how the brain communicates. This is not just a temporary adjustment. It leads to lasting physical changes that support learning and memory. During infancy and early childhood, structural plasticity is particularly active. The brain is highly receptive to environmental stimuli and experiences. This is when the formation and pruning of synaptic connections take place. This dynamic remodeling shapes the brain's architecture, influencing cognitive, motor, and sensory abilities as a child grows. Key processes involved in structural plasticity include synaptogenesis, which is the creation of new synapses, and dendritic remodeling, which adjusts how neurons receive signals. There is also neurogenesis, the birth of new neurons, which is more prominent in early development. Pruning is another important process where weaker or unused synapses are eliminated, refining neural circuits for better efficiency. These changes allow the brain to adapt to new skills. For instance, when an infant learns to grasp objects, structural plasticity supports the growth of neural networks in the motor areas of the brain. This establishes strong connections that improve coordination. From a practical standpoint, providing a rich and stimulating environment during early childhood is essential. Experiences like talking, playing, and exploring help develop the neural circuits needed for learning and behavior. On the flip side, a lack of stimulation can limit these structural changes and affect development. In essence, structural plasticity changes your brain's wiring by physically reshaping neural connections. This is especially true during infancy and early childhood when the brain is most adaptable. This rewiring lays the groundwork for learning, memory, and overall neurodevelopment.